just calculate the probability. But it's going to be probability in relation to geometry, geometric probability. So a couple of things that are important about probability as you head to your future math courses. Number one, I want to encourage all of you to strongly consider taking AP Statistics in the future. I will tell you it's a very hard class, so it's not going to be something super easy. But when you decide what you're going to do as a career, when you're thinking about what am I going to do when I get out of high school, if you have to take statistics in college, so when you start to think, I think I want to be a physical therapist or whatever, you should go and look up in the course catalog for whatever college you're thinking about going to by next year or your junior year and look to see what is the first math class or what are the math classes I have to have. Do I have to have college algebra? Is that my basic math? Do I have to take statistics? Do I have to take calculus? Because if you have to take statistics, and this is just my opinion, my advice, but if you have to take statistics in college, it's going to be so much easier for you to take it here at the high school in a small class with a teacher than to wait till you go to college and try to take college statistics in a big giant class with a professor that's not going to have maybe near as much one-on-one time with you as you would have here at the high school. So the statistics teacher is Mrs. Siegert. She has an amazing record for student scoring on her AP statistics exam. Last year, 100% of them scored and got college credit. So if you take that, then you would walk into college with your statistics credit and you wouldn't have to take it in college. So with that being said, the reason I'm bringing that up right now is in statistics, you're going to talk about probability. And so if you do take that here at the high school, I want to make sure that I'm preparing you for that the way that I know Mrs. Siegert's going to want you to write that. And also you're going to do probability in Algebra 2. So whether you take statistics or not, you're going to take Algebra 2. And when you do, they're going to have a probability unit in there and they're going to want you to write it a certain way. So I'm going to try to prepare you for both of those. But I just wanted to give a shout out to our statistics class because I do feel like it will help you if you have to have statistics. And a lot of students don't realize they have to take statistics in college. They think college algebra or calculus, but a lot of majors are going to statistics as the basic math class. So if you're thinking about business, I know for sure business you have to have statistics. So just think about that and look into that before you choose your junior level and senior level math classes, okay? So geometric probability is going to be similar to what you did in Algebra 1 with probability. So just remind me, when you were in Algebra 1, did you guys talk about maybe some simple questions like, if I have a bag of marbles and I stick my hand in the bag, what's the probability I pull out a red marble? Yes? Okay. So how would I do that? If I had, let's say, 30 red marbles and 100 marbles in my bag, how would I find the probability that I pulled out a red one? A ratio. And what would my ratio look like? 30 out of 100. So why did you put the 30 on top? Okay, that's the part that I want to find the probability of. That's my event. And on the bottom, we put 100 because that was what? The whole thing, the total. So the exact same thing for 10-6 today with us. When we want to find the probability of something, we're going to put the probability of our event, whatever that is for geometry, and on the bottom of our fraction is going to be the entire sample space. So whatever that is for our geometry problem, it's the total. Something that you need to be aware of is there's different types of probability. We're going to be looking at theoretical probability, so theory, if we did this, what would happen? And we're going to be talking about equally likely events, meaning if I say, what's the probability that I hit a hole in one, we're going to pretend that we have the same skill level. That's equally likely, not like I'm going up against Tiger Woods trying to hit a hole in one. Okay, so that would not be equally likely. So we're theoretically what would happen, and we're assuming that there's an equally likely chance of it occurring. Okay, it would be different if that were not the case. Okay, so just some simple probability. For geometric probability today, we're going to be talking about geometry concepts. So we're going to be looking at things like length or area. Couldn't find my word there. So we're going to be looking at things like length or area. So I'm going to jump right to our little chart and show you the 3 different ways you're going to have to find probability today. You're going to have to find the probability maybe in terms of a line segment. They may ask you, what's the probability that your point is on line segment BC? When you write your answers, and I'm going to be super picky about this because I know that your Algebra 2 teachers will be, you're going to write your work as probability of, and inside your parentheses you need to list the event, whatever it is. So probability that it's on line segment BC, or probability that it is in the shaded area. Okay, so on every problem, probability in parentheses, what's the event that you're trying to find? Then you're going to write your probability as a fraction, what you want out of the total. So we would find what in this case if we want to find the probability of BC? The length of BC over the length of AD. You guys with me? What we want over the total. Those should be pretty easy. You'll just be counting or finding those distances. If you look at a circle, we haven't really learned anything about circles much yet other than area. We're going to in chapter 12. But in this case, if we want to know the probability of the shaded part, we can just simply think about it in terms of angle measures. What's the total measurement of a circle? 360. So that would go in the bottom. And then if I told you that this angle was 30 degrees, then you would just put 30 out of 360. Does that make sense? Okay. And if it's something more complicated, like the last one here, where you have different shapes, if I want to find the probability of the shaded region, what would I need to calculate? The area of, okay, be specific, what would go on top? Area of the triangle, and then on the bottom, the area of the rectangle. Okay. Your answers for probability should be between a range of values. So when you talk about probability, like for example, if I say, what's the probability it's going to rain today? What are some options you could have for your answers? Say it again. 40%. What are some other options? 0%. So what would be the range of possible answers I could have? 0% to 100%. So you should never get an answer that's over 100, or you should never get a negative answer. What if we wrote those as fractions? So what would be my range of numbers written as fractions instead of percentages? 0 to not 100. What does a percentage mean? Percentage means what out of 100? So 0 out of 100 is 0. 100 out of 100 is 1. So you're either going to have an answer from 0 to 1, or you're going to have an answer from 0 to 100%. I will accept both answers either way if the book doesn't specify. But if it specifies, like round to the nearest 10th, you're going to have to round to the nearest 10th. So do whatever the book says. Okay, we're going to do a couple examples. I'm not going to spend a lot of time on this, but we'll do a few just to make sure you're getting it. But before we go any further, sometimes they're going to ask you to find the probability of not an event. So if you tell me there's a 40% chance of rain today, what's the probability that it will not rain today? 60. So just a reminder that if you want to find the probability of something not occurring, you can do 1 minus the probability that it does occur. Or 100% minus the probability that it does occur. Depends on how you're writing your answer. If you're writing it as a fraction, it would be 1 minus. If you're writing it as a percentage, it would be 100 minus. Everybody with me there? Okay. So let's look at just a couple different scenarios. So first one, find the probability that a point is on RS. What am I going to put inside my parentheses? RS. All right. What's going to go on top of my fraction? What is RS? 5. What's going to go on the bottom of my fraction? 25. Where did you get 25? The whole line segment. Okay? You are not allowed to leave your answer as 5/25ths. You're either going to write it as a fraction in simplest fraction form or as a percentage. Your choice on the homework. Just be consistent. Make sure you're rounding correctly according to directions if it tells you to. So what's 5/25ths as a fraction? 1/5. So you could write it as 1/5. Or what is 1/5 as a percentage? 20%. How do you change a fraction to a percentage? How do I change a fraction to percentage? If I take 1/5 times 100, that doesn't give me 20. So what do I do first? Okay, but what Martin said, change it, multiply so that your denominator becomes 100. So 5 times what is 100? 20. So 1 times 20 is 20. But what happens whenever I have something like 2/3? I can't multiply that to make it 100. But again, if I multiplied this by 100, that's 200/3. That's not the same. You got to do something before you multiply it by 100. If I'm trying to write it. Okay. So, and then what do I do? Which is what you have there, Jedi, 200/3. But what I'm trying to get you to do is tell me, how would I write that as a decimal percentage, I guess, is what I'm asking. So you could do exactly what Jackson said, cross multiply, which is going to give you exactly what Jedi just said. It's going to give you 200/3, right? Which is what, though? Right, so what you're saying there, Jackson, is this would give you 3x equals 200. You're going to divide by 3. That still gives you what Jedi said, 200/3. But what is that as a percentage in decimal form? 66 and, okay, or 66 and 2/3%. So you can either write it as 66.7%. They're going to ask you on the homework to round to the nearest 1/10 of a percent, 100th of a percent. So just be able to plug that in and round that. But you are correct, Jedi. You could have just taken it and multiplied it by 100, but then be able to change that to a percentage in decimal form. Any questions there? Okay, I may have made that more confusing than I needed to. All right, I'm going to skip this one. And let's look at this one. Find the probability that the point is on PQ or QR. So what does that mean? Say it again. Add those together. So probability of PQ or QR, don't forget to write what you're finding in your parentheses. So that means it could be on PQ or QR. Add them together. What do you get? 20 out of 25. Tell me what that is as a fraction. What is it? I'm sorry? 4/5. That could be your answer. Or what is it as a percentage? 80%. Okay, so I think we're doing fine with those. Look at the next one. Talk to your partner and see if you can answer this one. Okay, so first of all, what's going in my parentheses? Walk. Make sure you're identifying what you're finding the probability of. And again, I'm being super picky just because I know where you're headed and they will be picky. So if you get in a good habit now, it'll make it so much easier later. All right. How much time is it walking? 45 seconds. What's the total amount of time? 1:15. Good. You got to add those together. Simplify that. What does that reduce to? You could leave it as 9/23, or you could type that into your calculator and round to the nearest whatever, if it doesn't tell you. Again, I will accept your answers on your homework either as fractions or as percentages. You choose how you want to write your answer. Just round appropriately if you round it. Any questions here? Okay, moving on. The next kinds of questions you're going to see should be pretty easy. I'm going to skip these. Actually, let's try this one. What's the probability that the light will not be on red? So what's going in your parentheses? Not red. What's one way we could figure out the probability of not red? Just do green and yellow. So how much of our line is green and yellow? 30. And that would be 30 out of 60, which is 1/2, which is what percentage? 50%. You could do it that way, or remember, you could also find the probability that it is red and then subtract it from 1 or 100, depending on if you wrote it as a fraction or a percent. Questions on those? Okay. The next problems you have in your notes are all about spinners or circles. So those should be pretty easy. I'm going to skip this one and go to the last one. So one more time. What's the probability that the pointer does not land on green? So not green. So in our parentheses, we're going to put what? Not green. What's our total going to be on the bottom? 360, because it's a circle. So how do you want to find not green? Okay, so you could find the probability that it is green and then subtract it from 1. So what's the probability that it is green? Okay, it would be 108 out of 360, which is 1 minus 3/10. So what is my probability that it is not green? 7 out of 10, or 70%. What's another way we could have done it besides finding the probability of green and subtracting it from 1? Add all the other ones together. What do all those add to be? 252. What's 252 divided by 360? 7/10, or 70%. Are you guys with me there? Questions one way or the other? Okay, again, I'm skipping a lot because I think this is pretty easy. Last thing that's in 10.6. This is going to be more like if you were playing darts and they say, what's the probability that you hit the bullseye on the dartboard? That's where you're going to have to find the area of the bullseye and the area of the dartboard. So this was the same kind of question here. It says find the probability that a point chosen randomly inside the rectangle is in each shape. Round to the nearest hundredth. And then I gave you 3 different questions. Do you guys see on your notes? The first one says the circle. So find the probability that if you pick a point out of here, it is in the circle. The second one says the probability of what? Trapezoid. So find the probability that if you picked a point out of the trapezoid, it lands, or out of the rectangle, it's in the trapezoid. And then what's the last one say? One of the 2 squares. So again, if you think about it like a dart, if you were throwing the dart at the rectangle, what's the probability that it lands in one of these 2 squares? Okay, we're not going to do all 3 of these. Let's just talk about what you would have to do. So if I wanted to find the probability of the circle, what do I need to find? Area of the circle over area of the rectangle. Okay, that's all I'm going to do for the first one. You guys can calculate areas. So on the next one, if I want to find the probability of the trapezoid, what am I going to need? Area of the trapezoid divided by area of the rectangle. Am I going too fast? Questions? Okay, I'm not going to do that one either. Let's do the last one. So when it says find the probability that it is in one of the two squares, what am I going to need to find? Area of one square? So that would mean that the only place my dart could land is in this one square. But if it says what's the probability that it's in one of the two squares, how many places could my dart land? Could land in either one of these, right? So what do I really have to do besides find the area of one square? Okay, add both of them together. But what do you notice about the two squares? They're the same. So I can find the area of one square and do what? Multiply it by 2. And then find the area of what? The rectangle. Okay, let's do that. So I'm going to go up here and show my work. What's the area of a square formula? Side squared. What's the side length of the square? 10. What is 10 squared? 100. So if I plug that in here, I have 2 times 100 over. Now let's find the area of the rectangle. What's my formula? Base times height. What's the base? 50. What's the height? 28. What's 50 times 28? 1,400. So now we put that in the bottom. That gives me 200 over 1,400, which reduces to 1/7. It said round to the nearest hundredth. So what is 1/7 as a decimal? Okay, I heard 0.142857. Let's round that as a percentage to the nearest hundredth. So percentage would mean move the decimal 2 places to the right or multiply that by 100. So what would that be to the nearest hundredth of a percentage? Nearest hundredth of a percentage. I heard 2 different answers. 14.29. Hundredth would be the second number. So 14.29%. Everybody clear there? Okay, I'm going to promise you that some of these problems are going to be a little harder on your homework as far as calculating areas go. But the concept is the same. Just what you want over the total to find your probability. Any questions on 10.6? Okay. 10.5. Go to 10.5. All right, 10.5 could be short, it could be long. It's going to depend on how well you understand the shortcuts. I'm going to work it the shortcut way and the long way, not long cut, long way. And then you're going to tell me what you understood, and then if you aren't getting it, we're going to keep working it the long way until we get really good at it, okay? But 10.5 is basically going to ask you to describe what happens to your shape's perimeter or area when you change the dimensions. All of your answers on 10.5 should be complete sentences. No just numbers. So you're going to be giving me answers like the area is multiplied by 5 or the perimeter is multiplied by 2/3. You're going to be writing a sentence telling me what happened to the perimeter, what happened to the area. Sometimes you'll be able to see a really quick shortcut and there won't be any work for you to show on your homework. You can just write out your sentence. If you see the shortcut, you do not have to show me work. Sometimes you're going to struggle with what is the shortcut and you're going to need to investigate it. Then you need to show me your work to investigate it. Most of the time you'll be able to use the shortcut. Sometimes you won't be able to use the shortcut and you'll have to investigate it because there's not a shortcut. So I'm going to look at it both ways and then you're going to decide what makes most sense to you. Okay? So the shortcut way is to look at the formulas. So the question says, describe the effect of each change on the area of the given figure. So this is just asking about area. And the directions say that the height of the triangle is going to be multiplied by 6. Okay, so first of all, before we go here, Remind me back to elementary school. If I do 2 times 3 times 5 times 6, is that the same as 5 times 2 times 3 times 6? Okay, take your calculator, multiply it. What's 2 times 3 times 5 times 6? 180. Take your calculator and do 5 times parentheses 2 times 3 times 6. Is it the same? Yes, because multiplication, the order does not matter, right? You can switch the order around and you still get the same answer. And all I did was bring the 5 out front. When you multiply, you just multiply from left to right. Even if you're doing what's in parentheses first, you're still just multiplying from left to right. Does that make sense? Okay, so keep that in mind. Now this is the shortcut way. If this doesn't make sense on the board, I'm going to do it the long way. So you're going to start with your formula. What's the formula for area of a triangle? Okay, 1/2 base times height, or base times height divided by 2. What did they say that we're going to do to the height in this problem? Multiply it by 6. So what I'm going to do is I'm going to plug in, instead of h, I'm going to multiply h by 6. So I'm going to plug in 6h. And since all of these are multiplied, I can just move that 6 out to the front. So really I have 6 times 1/2 base times height. So what's going to happen to my overall area when I multiply the height by 6? The area is going to get multiplied by 6. So your answer would be the area is multiplied by 6. Complete sentence. That's your answer. Yesenia, stay with us. You need to write this down. Is everybody with me there? Raise your hand if you really understood that. Okay, here's the long way that you would have to do it if you don't understand, or please listen, sometimes there's not a shortcut. Sometimes looking at the formula will not make it clear. Sometimes you have to investigate it. So if you have to investigate, this is what you would do. You would find the area of the original triangle. 1/2 base times height. What's the base in the picture? 12. What's the height in the picture? 5. What's half of 12? Times 5, 30. So we have 30 square inches. Everybody okay with finding the area of the original triangle? Okay. Then it says multiply the height by 6. So now my height's no longer going to be 5. What's 5 times 6? 30. So now my height is 30 inches. So then you'll find the area of your new triangle. It's still 1/2 base times height. Your base is still 12. But your height is now what? 30. What's half of 12? And what's 6 times 30? 180. Sometimes you'll be able to look at those two numbers and you'll have a nice, pretty whole number, and you'll be able to say, how many times bigger is it if it went from 30 to 180? So 30 times what is 180? 6. So the area is multiplied by 6. Sometimes this is going to be an ugly fraction. So you're going to need to do it this way. The area of the new divided by the area of the original. It always has to be the new one on top. Okay, so the area of the new shape divided by the area of the original shape. So the new shape was what area? 180. And what was the original area? And what's 180 divided by 30? 6. Again, your answer is not 6. Your answer is the area would be multiplied by 6. Complete sentence. Shortcut, you can look at the formula. Long way, you calculate the two areas and you divide them. New by old. Questions? Okay, let's try another one. Anybody need time to write that down? I went too fast. Okay, I'm going to slow down for just a second. You go ahead and look at the next one and take your guess on what you think the answer is. Okay, let's look at this problem. What are you going to need to do? First of all, what are we talking about here? A kite, and the directions are the same as the last question. Describe the change that would happen to the area if what is happening to the kite? What does it say is happening to the kite? The diagonal SU is being multiplied by 1/3. Okay, so we're trying to describe what's happening to the area if the diagonal is multiplied by 1/3. So again, without graphing or doing it the long way, we're just going to look at the formula first. So this is the shortcut. What's the formula for area of a kite? 1/2 D1 times D2. Okay, what are we changing in this formula? SU, which is just one diagonal, right? Okay, so we're going to take one of our diagonals and we're going to multiply it by what? 1/3. So instead of having 1/2 times diagonal 1, I'm going to change diagonal 1 to 1/3 of diagonal 1. And then I'm going to multiply it by the other diagonal 2. You guys with me? All right, and is all of this just multiplied? Okay, so if it's all just multiplied, then I could bring that 1/3 out front so that I have 1/3 of 1/2 times diagonal 1 times diagonal 2. So what's happening to the original area when we multiply one diagonal by 1/3? It's multiplied by 1/3. And again, you have to write it as a complete sentence. The area is multiplied by 1/3. Now, if we didn't do it the shortcut way, what would we have to do to figure out how the area changed? We'd have to graph it. I don't think we'd have to use the distance formula. Let's graph it real quick. Get up and grab a sheet of graph paper. Everybody, wake up. Grab a sheet of graph paper. Mm-hmm. So we're getting ready to look at a general rule where you can make that assumption every single time. But looking at the formula, it depends on if we're only changing one diagonal or we're changing both diagonals or if they're each changing by something different. Because if the second diagonal changed by something too, then we couldn't just put that 1/3 in front because we would have another number here, and that's what we're going to look at. Okay? So I'm just trying to get us seeing it, and then we'll write a general shortcut. Okay? Okay, quickly, graph paper, let's graph it. Mm-hmm. And mine's not going to be perfect up here because I just made my own graph, but it should look something like that on yours. And we have what shape again? Kite. And so when we graph it here and we're looking for the diagonals, would you agree now that it's graphed that we're not really going to have to use distance formula? Because we can find SU. What's the length of SU? 9. And then the second diagonal would be RT, which ends up being vertical on your paper. Mine looks a little diagonal, but yours is vertical. And what is RT's distance? 4. And all we need to calculate the area is the diagonals. So we have area of the original is 1/2 diagonal 1 times diagonal 2, which you just told me was 9 and 4. So what do we get for the area of this original kite? Okay, 1/2 of 36, which is 18. So remember, if you're doing it the long way, you're finding the area of the shape, and then you're doing whatever it tells you to do to the dimension, which was multiply SU only by 1/3. So now I'm going to come over here and multiply SU by 1/3. So what is 9 times 1/3? 3. So my new diagonal is 3 and 4. So now I'm going to calculate the area of the new kite, which would be 1/2 of diagonal 1 times diagonal 2. 1/2 of 3 times 4. What's 3 times 4 times a half? 6. And then remember that you're doing the new one divided by the old one. I always have students who go, oh, the area was multiplied by 3 because 18 divided by 6 is 3. But that's not what you do. You do the new one by the old one. So the area of the new divided by the area of the original is going to be 6 over 18, which reduces to 1/3. So you would have to do all of this work to investigate it, or you can look at the formula and say, oh, the area is multiplied by 1/3. So what I need to know is right now, do you understand one of these two ways? Raise your hand if you understand at least one of the two ways. Okay, so let's make a general statement on our paper that makes this shortcut a little easier. How many dimensions did we change in our problem? 1 on both of them, right? This one we only multiplied the height, and this one we only multiplied the diagonal. So write this down because this is not in your notes anywhere. If only one dimension is multiplied by, and I'm going to put A. It can be any value. So if only one dimension is multiplied by A, then our shortcut rule would say, then the area is multiplied by A. And you would have no work to show. If they say you have a rectangle and the base is multiplied by 5, what happened to the area? You could say the area is multiplied by 5, and you wouldn't have any work to show. That's your first shortcut. There's 2 shortcuts. Questions here? Okay, the only problem is when you change only one dimension, you don't have a rule of what happens to the perimeter. So if your book asks you what happens to the perimeter, you're going to have to calculate the original perimeter, calculate the new perimeter, and divide them, because the perimeter, there's not a fixed shortcut that works every single time for all shapes, only if it's the area. All right, now let's look at a different situation. So look at the next question. What does it ask us to do? So it wants us to figure out what happens to the perimeter or circumference and the area. And what are we doing to our shape? We're doubling what? Both dimensions, both the base and the height. Okay, so we have 2 answers. We're going to have an answer for what happens to the perimeter, and we're going to have an answer for what happens to the area. So you'll have 2 sentences, and this time you're changing 2 dimensions. So again, I'm going to look at shortcuts, and then I'm going to look at the long way. So let's start with the shortcut. What's the formula? We'll do area first, since we've been talking about area. What shape do we have here? Rectangle. What's the area formula for a rectangle? Base times height. So first of all, how many dimensions does a rectangle have? How many? 2. Has 2 different dimensions, right? It has a base and a height. So when we change both of them, we're changing all of the dimensions for the rectangle. Would you agree? Okay. And so what does double mean? Multiply by 2. So in my formula, that means I'm going to change B to 2B. And I'm going to change H to 2H. So simplify that. What is 2B times 2H? 4BH. So what did we do from the original formula to the new formula? Multiplied by 4. So the shortcut would be plug it into your formula, look and see what happened, and now we can say the area is multiplied by 4. But notice, when we multiplied both dimensions by 2, it did not multiply the area by 2, right? It multiplied the area by 4. So that's different. Okay, let's try it with perimeter. What's the perimeter formula for a rectangle? 2b plus 2h. Okay, but now we're going to take the base and we're going to multiply it by what? We're going to double the base and double the height. So we're going to multiply the base by 2. So where this was a b, we're now putting 2b. We still have a 2 in our formula. And then where there's an h, we're going to put 2h. Is everybody following me there? Okay, simplify. What's 2 times 2b? 4b. And what's 2 times 2h? 4h. Now compare this formula to this formula. What did we do to this formula to get this formula? We doubled it. So we would say that the perimeter, you could either say is doubled, or you could say the perimeter is multiplied by 2. And you can write it either way. The perimeter is doubled or the perimeter is multiplied by 2. Do you see the formula shortcut way? And in a minute, we're going to write out just a general rule that's a shortcut too. Okay, so what do you think when you double both dimensions or you change both dimensions? What do you think the general rule is for what happens to the perimeter? Okay, so Christian said whatever you're multiplying both the dimensions by, that's what's going to happen to the perimeter. So if you multiply both dimensions by 5, the perimeter is multiplied by 5. Okay, that's what we think. So what about area? What do you think the general shortcut would be? Whatever you're multiplying both dimensions by, what happens to the area? So we think it's squared. Anybody think something different? Okay, let's check. Let's try the next one. One more and then I'm not going to work this the long way this time. I will on the next one, okay? The long way would be find the area of it originally, find the area of it new, divide them. Find the perimeter of it originally, find the perimeter of it new, divide them. But to save time, I'm going to do it on the next one. Okay, here's the next one. So same directions. What's going to happen to the perimeter and the area if we multiply the radius of this circle by 1/5? So let's start with our shortcut. So start with area. What's the formula for area of a circle? Pi r squared. What are we doing to the radius according to this problem? Multiply by 1/5. So where we have the letter r, we're going to put what in its place? 1/5 r, and then we're still going to square it. Okay, when we have 1/5 r squared, that means you have to square the 1/5 and square the r. So what is 1/5 squared? 1/25. You have to square the 1, which is 1, and you have to square the 5, which is 25. And then r squared is just r squared, right? And then because this is all multiplication, is it okay if I just bring this 1/25 out front? And that's the same as 1/25 pi r squared? So what happened to the original area to now? It was multiplied by 1/25. So our answer would be the area is multiplied by 1/25. Again, complete sentences. So Devin said he thinks that whatever you multiply both dimensions by, that you just take that number and you square it. Is 1/5 squared 1/25? Okay, so I think Devin's right. Let's try the perimeter, which wouldn't be called perimeter for a circle. It would be called circumference. What's my formula? 2 pi r. Again, what are we going to do to the radius? Multiply it by 1/5, so we're going to put 1/5 r in our formula. And then again, this is all just multiplied, right? So order doesn't matter, so I'm going to take this 1/5 and bring it out to the front. So I have 1/5 of 2 pi r. So when you compare the original circumference to the new circumference, what are we multiplying the circumference by? 1/5. The same thing that we multiplied the radius by. So we would say the circumference is multiplied by 1/5. Full, complete sentences. Now, here's where things get a little tricky. When you look at this circle, according to the formula, how many different dimensions does a circle have? Okay, careful, think dimensions. Dimensions would be like base, height, length, width, radius, base 1, diagonal 2, base 2. How many different dimensions does this circle have in its formula? Only one. It's a two-dimensional shape, but the dimension is the radius, right? And the radius is going in all directions, so it has only one different dimension. So when you change that one dimension, are you changing all of the dimensions? But when you think about the rectangle has a base and a height. If you only change the base, are you changing all dimensions? No. So what we just noticed when we looked at these two situations is if we changed both dimensions, which was all the dimensions, the area changed by that value squared, right? And if we changed all the dimensions, the perimeter changed by the same value. Same thing over here. If we changed all dimensions, which is just the one dimension here, the area was changed by that squared. And if we changed all dimensions, the circumference was changed by the same. Do you guys see the shortcut? Okay, it's in your notes. Look at your notes. Oops. Here's your second shortcut. It's written in your notes. I'm going to write it again up here on the board, though, so I can refer back to it in a minute, because we're getting ready to hit the hardest part. So here's the second shortcut. If all dimensions has to be all dimensions. If all dimensions are multiplied by, and again I'm going to call that number A. All dimensions are multiplied by A. We find out that the perimeter or circumference is multiplied by what? So if all the dimensions are multiplied by 5, what's the perimeter or circumference going to be multiplied by? 5. So if all dimensions are multiplied by A, then the perimeter or circumference is multiplied by A. Okay, the second thing we discovered was the area is multiplied by A squared. If you notice the shortcut and understand the shortcuts, you can use the shortcuts on your homework and you have no work to show. However, do we have a shortcut for what happens to the perimeter if only one dimension is changed? No. So then you have to find the perimeter of the original and the perimeter of the new and divide them if it is only one dimension. Now here's the tricky part. there are a few shapes, like the circle, that when you change only one of its dimensions, changes all of its dimensions because it only has one variable. So right now, talk to your partner and see if you can come up with every shape on your formula sheet that only has one dimension in its formula. Go. We already know circle is one of them. Okay, circle we already know. Circle is pi r squared. So when you change only one dimension, you're actually changing all dimensions, so it doesn't follow this shortcut, it follows the orange shortcut. What other shape do you know? Square. What's the area formula for a square? S squared, or perimeter is 4s. So no matter what you're finding, there's only one dimension. Even though it's a two-dimensional shape, the side length is the same, so when you change one dimension, you're technically changing all dimensions. Okay, what's another one? The equilateral triangle. And those are the only three we've talked about. Okay, equilateral triangle has the formula s squared, square roots of 3 over 4. And since it's equilateral, the perimeter would be the side length times 3, right? So it would be the same. So it only has one dimension. So when you change that one dimension, you're changing all dimensions. Now be careful. One of our regular polygons is made up of equilateral triangles. Which one of our regular polygons is made up of equilateral triangles? Hexagon. So technically, the hexagon would be the same. So we should probably write that down as well, because it's made up of equilateral triangles. So the hexagon is going to follow the orange shortcut as well. Does that make sense? Because it's just 6 equilateral triangles. And so when you change one dimension on that hexagon, you're changing all of its dimensions. Okay. Those are the shortcuts. Do I need to go back and work any of the problems the long way that I skipped? Anybody want me to go back and work one of them the long way by finding the perimeter of the old and the new, or the area of the old and the new? Okay, if you need me to personally, let me know. Let's look at the 2 harder problems at the end. I'm going to give you about 5 minutes. I want you and your partner to see if you think you can answer the last 2 problems, and then we'll talk about what they should be and how to do it. So we're going to go back over these. I'm going to show you both ways, because I'm seeing some of you who are having good success working it the long way, and some of you who are having good success working it the shortcut way. But I would love for the people doing it the long way to see the shortcut, because it would save you so much time. So I'm going to work it both ways. So I'm going to start with the shortcut. First of all, a circle has what formula for area? So how many different dimensions are in this formula? 1. So if you change this one dimension, are you changing only one dimension, or are you changing all of the dimensions? All of them, because it only has one. So you're using the orange shortcut, not the blue one. Are you guys with me there? Okay? And so the orange shortcut said that when all dimensions are changed, the area is multiplied by a squared. So if they tell you that the area is multiplied by 4, then 4 is equal to a squared. So what would I do to figure out a? Take the square root. So a is actually 2. So my shortcut says if all dimensions are multiplied by a, then the area is multiplied by a squared. So if the area is multiplied by 4, then the dimension is multiplied by, I need to make sure you're with me, Everybody up here listening? So if the area is multiplied by 4, then the dimension is multiplied by 2. Are you with me there? So the question says, if the area is multiplied by 4, what happened to the radius? The radius is the dimension, so the radius should be multiplied by 2. Now, some of you were working it the long way and probably want to figure out where you went wrong on the long way. So let me show you the long way really quickly, and then you stop me if you don't understand if I go too fast. So the long way would mean you need to find the areas and compare them to figure out what happened to the radius. So if they give you the circumference is 32 pi, what's the formula for circumference? 2 pi r. Okay, so I need to solve for r. What would I do? Divide by 2 pi. So what is my radius for this circle? 16. Everybody follow that? We're trying to figure out what happens to this radius if the area is multiplied by 4. So we need to find the area for this circle and multiply it by 4. So what would the area of this circle be? Pi r squared. So it would be pi times 16 squared. So what's the area? 256 pi. Okay, that's if I find this area. But now we're going to take that area and do what with it? Multiply it by 4. So 4 times the area becomes 4 times 256 pi. So what's 4 times 256? 1,024 pi. But that's the area, right? That's the new area. So what do I need to find to compare what happened to the radius? Not yet. If this is the new area and this is their old radius, and I'm trying to figure out what happened to the radius, what do I need to find out over here? The new radius. So my formula for area is pi r squared. So set your new area equal to your area formula and solve for your new radius. What would I do to solve for r? Divide by pi. So r squared equals 1,024. Take the square root, and what do we get? 32. So the new radius is 32. The old radius was 16. So what happened to the new rate to get the new radius? We multiplied by 2. You can take 32 and divide by 16 to get 2 times bigger. Now that's a lot of work when you could have just said, if the area is multiplied by 4, work backwards, take the square root, then the radius is multiplied by 2. Questions if you don't understand how to do it one way or the other? Please ask if you're lost. Okay, last problem. I never saw a correct answer. I saw one person on the right track, and that was it. So, here we go. Let's work this one together. First of all, it's an equilateral triangle, has a perimeter of 21. If the area is multiplied by a half, what happens to the side length? So one more time, you have to ask yourself, let's try a shortcut. Are we looking at only changing one dimension or all dimensions? It's an equilateral triangle, so it only has one different dimension, right? So when we change that one dimension, we're changing all dimensions. So it uses this orange shortcut. Would you agree? Okay, so they said the equilateral triangle has a perimeter of 21 meters if the area is multiplied by a half. So what is a half equal to in our shortcut? If the area is multiplied by a half. If all dimensions are multiplied by a, the area is multiplied by a squared. What is 1/2 equal in this shortcut? A squared. Everybody agree that it equals a squared? If the area is multiplied by a half, So 1/2 equals a squared. The question is, what happens to the side length? If all dimensions are multiplied by a, the side length is a dimension. We're trying to figure out what is a. So what am I going to do to solve for a? The opposite of squaring is square root. Take the square root. You are not allowed to give me a decimal because it does not say to round, and you should not have a square root in the denominator. If you have a fraction under a square root, you have a square root in the denominator. So what would I do to simplify this? Before I do that, what would I do? Say it again. Take the square root of each one separately. What is the square root of 1? 1. And then we have over the square root of 2. We can't leave that, so Sean said we need to multiply by square root of 2 over the square root of 2. So what do we get? Square root of 2 over 2. So what happened to the side length? It was multiplied by the square root of 2 over 2. So the answer would be the side length is multiplied by square root of 2 over 2. Questions if you don't understand how we got that? Does anyone want me to work it the long way? Okay. That's the big idea. That's really as hard as they get, but there are some problems on the homework that make you think a little bit. This is our last homework assignment before the test. This is due Friday, and it is all out of the textbook. Again, if it is a shortcut problem, you don't have to show work if you can figure it out with just the shortcut. But if you aren't using the shortcut, show your work. And if you need me to come help you one-on-one with any of this because you're still kind of foggy, get my attention because we still have 10 minutes.